Welcome back to part two of modern application platforms in the VCPP program. So in this section, we're going to take a look at an overview of the VMware Tanzu portfolio and kind of have a look at the roadmap of how we see this integrating into the VCPP program, especially with respect to VMware Cloud Director. But before we get into what this looks like in VCPP and kind of the integration points with VMware Cloud Director specifically, I want to take a look at the Tanzu portfolio in general. Now, as I just said, VMware Tanzu is actually an overarching brand or a portfolio of solutions. It's not just a single product. We have things like Spring Runtime, Tanzu Build Service, Tanzu Application Service that come from the Pivotal acquisition, the Tanzu Application Catalog that is an evolution of the Bitnami catalog. We have our Kubernetes Runtime and Tanzu Kubernetes Grid and its integration with vSphere 7. We have our multi-cluster and operations management platform with Tanzu Mission Control, and then Tanzu Observability by Wavefront for monitoring and observability of application and application infrastructure. Really, this is our view of kind of the best way to support a modern application platform and as well as enable building those applications on that platform. But in this session, we're really going to focus on kind of the Kubernetes runtime and a little bit on Tanzu Mission Control to see how that might play into the VCPP partner Rolodex. So as I just called out, we really have kind of three distinct, quote unquote, distinct products we're going to focus on in the session. First, vSphere 7 with Kubernetes. So this is Kubernetes kind of deeply integrated into the vSphere core product. We also have Tanzu Kubernetes Grid, which is our supported Kubernetes runtime that also includes lifecycle management via Cluster API for vSphere. And we also will have a look at Tanzu Mission Control, which is our multi-cloud, multi-cluster management platform. And really, the basis at the at the foot of all of these technologies is a project called Cluster API. And so, Cluster API essentially is an open source project that allows users to manage and deploy Kubernetes clusters with Kubernetes style APIs and declaratives. So just like a user would deploy a pod to a cluster, a user can use and utilize what we call a management cluster or a management endpoint to deploy Kubernetes clusters itself. So basically, this management cluster or endpoint communicates with some sort of API-driven infrastructure like vSphere to create virtual machines, to monitor them for health, to instantiate them as nodes in a cluster to scale things up and down. So all of that, these kind of product lines that we see on the screen utilize Cluster API for lifecycle management. And so that is kind of in various kind of implementations is the management endpoint for managing and deploying Kubernetes clusters in VMware environments. So let's take a look at these different products and understand exactly what they're comprised of. So vSphere 7 with Kubernetes is really VMware vSphere 7.0, NSXT Data Center 3.0, deployed and managed by VMware Cloud Foundation. So VMware Cloud Foundation is the licensing mechanism for vSphere 7 with Kubernetes. And essentially what we do to kind of layer the Kubernetes solution on top of this foundation is what we call enabling the workload control platform or the workload platform, as well as the Tanzu Kubernetes Grid service. So the TKG service is really kind of the cluster API style component of managing and deploying Kubernetes clusters. So if we have a look at this from kind of the VI admin's perspective, they install ESXi, they install use VMware Cloud Foundations to install vSphere and NSXT and configure, do the kind of the baseline configuration. And then in the vSphere HTML5 client, there is a menu for workload management, and they walk through the process of enabling what we call the supervisor cluster or the management cluster of the vSphere 7 with Kubernetes component. So what this does is essentially deploy 3 virtual machines in the cluster and install the cluster API style management components on this virtual machine. And we also install what we call a spherelet, which is similar to a kubelet in Kubernetes terms, to allow users and developers to run what we call vSphere pods directly on the ESXi hosts. So we're really turning the ESXi hosts and the vSphere cluster into a Kubernetes cluster, and we're also installing management components that will allow developers to deploy their own workload clusters, we call them, via cluster API style declaratives. So this is what comprises the supervisor cluster, and this is the management endpoint for creation of Kubernetes clusters and other resources in the environment using Kubernetes style declarative APIs and YAML configuration files. So the developer who already uses tools like kubectl to interact with their Kubernetes environment will use the vSphere plugin to actually use vSphere SSO credentials to log in and authenticate against the supervisor cluster. This will allow them to then use the kubectl command to essentially apply or create a Kubernetes cluster by using a YAML file that defines the configuration of the cluster, the number of worker nodes, the number of control plane nodes, the vCPU and memory configuration. So that is all the user will need to do, pass that configuration file to the supervisor cluster, and the supervisor cluster will be responsible for creating the Kubernetes cluster for that user. And so as you can imagine, this can scale out fairly quickly to allow that developer, that team of developers, to deploy and manage as many clusters as they want. So this is really the Kubernetes deeply integrated with vSphere 7 solution from a high-level architectural standpoint. So we also have what we call Tanzu Kubernetes Grid Standalone. And so this is really the productized offering of VMware signed Kubernetes binary, kind of without that high level of integration or requirement for vSphere 7 and NSXT 3.0. So support is provided for TKG standalone lifecycle management via cluster API. We support Calico as the container network interface. We also provide support for Contour for ingress, as well as FluentBit for observability. TKG today is supported on vSphere 6.7 Update 3, as well as AWS and EC2 instances. We also offer TKG Plus, which is kind of an additional level of support guidelines and infrastructure zones. So for TKG Plus, we also add availability and support for deploying and managing clusters on VMware Cloud on AWS. We provide support for Harbor, Sonabuoy, Valero, Dex, and Gangway for authentication, as well as a wider choice of observability tools. So TKG Plus just gets you a wider guardrails for open source solutions that VMware will support. So from an architectural standpoint, this looks a little different because it doesn't have that deep level of integration with vSphere, and it is deployed on, supported on 6.7 Update 3 or EC2 or VMC on AWS. So from an enablement perspective, the VI admin uses the TKG command line tool provided to start the installation process. Now this brings up a web UI that has a dialog that asks for information about the landing zone or landing area for the deployment. So whether it's going to be on vSphere, AWS, if it's on vSphere, what's the URL for the vCenter appliance, what's the data center resource pool cluster, where are these things going to live? And so once that's filled out, the TKG command line tool reaches out to the vCenter or the AWS or the VMC environment and provisions virtual machines and instantiates them as the TKG management cluster. So this workflow is a little different. The developer uses a TKG command line to authenticate against the management cluster, and then uses the TKG command line to create their cluster. So from a high level, the workflow is very similar to what we saw in the previous section with the supervisor cluster, but the deployment method is a little bit different. We don't have the NSXT as the container network interface for these clusters. So that means on one hand, NSXT is not required, so a little bit more flexibility in the deployment model, but it also means we don't yet have that deep integration on the networking side for the clusters. And so again, as you can imagine, we're still using kind of cluster API declarative, so this can scale out pretty quickly and allow our developers or teams of developers to quickly provision clusters at scale and manage clusters at scale. So that covers it from the runtime perspective. I just want to spend a second talking about Tanzu Mission Control, which is our SaaS platform for centralized management of policy and security for clusters across all teams. So Tanzu Mission Control can attach to any CNCF conformant Kubernetes cluster and layer policy and security specifications on those clusters. So you can fan out your security and policy access best practice across your entire infrastructure from Tanzu Mission Control. It can also provision Tanzu Kubernetes grid clusters on AWS today, and then coming very soon on vSphere 7 and 6.7 update 3 as well. And so when you provision a cluster via TMC, you have full cluster lifecycle management from the Mission Control portal. So you can scale and upgrade these clusters directly from Mission Control. So the vision is eventually being able to kind of have complete control, policy, security, lifecycle management from the TMC portal directly. So what does this look like, and what is the roadmap for how this fits into the VCPP program? So I hope that what I've kind of laid out is a decent high-level overview of the different Tanzu runtime and management solutions that we have. So as I mentioned earlier with respect to CSE, if you think of CSE as kind of our Kubernetes adapter, on the left today it supports CSE standard and VMware PKS or Tanzu Kubernetes Grid integrated as Kubernetes endpoints, and we also envision that this will allow us to onboard these additional new Kubernetes runtimes in vSphere 7 with Kubernetes, as well as TKG standalone with CSE as the front end of the solution. So, the takeaway here is that at least with CSE standard, that is really a great starting point for our cloud providers. Because it's not very invasive, it doesn't require a large investment especially of new technology, because it doesn't require things like NSXT. But it sets you up to understand and learn about the server management process for the CSE, the installation process. And then once we kind of firm up the technical integration with CSE, that will allow you to bring, for technical integration with CSE for the additional Kubernetes runtimes, that will allow you to kind of slide those in under the control of CSE and onboard those services into VMware Cloud Director, pretty easily. So today, we don't have obviously support or pricing for the roadmap solutions on the right, but our BU is hyper-focused on both making pricing available, as well as having a technical kind of reference architecture for deploying these new solutions in conjunction with VMware Cloud Director. So that wraps it up for our overview. I hope that's been kind of useful and informative, and we'll have a demo recording on CSE as it exists today as well shortly. Thank you.